let's talk a little bit about passwordless authentication, because this is really where we're going as a security culture. We want to be able to get away from that reliance on remembering passwords, on using password managers, things like that. One of the best ways that we can go about doing that, especially right now, is through the use of what's called a passkey. And a passkey basically combines all the things that make the blockchain secure, along with what makes authentication secure in the first place. And what we're really talking about here is going to be public key cryptography. We have a webinar on this if you'd like to take a look at it. But what we're using is a device that we already have, know, and trust that we can authenticate with biometrically, not having to use a username or password, and that can basically be our key into multiple services. There's a couple different large-scale vendors out there who are already rolling this out for or on a large scale. One of them being Apple. So Apple is operating under the Apple passkey model right now. This is based on a couple of standards that are pretty well known in security circles that are becoming well known among other technical circles, but they're based on the FIDO standards and the W3C standards. We'll talk about these a little bit as we go through, but it replaces the need for a password with a public and private key pair, an encryption key pair. The same way that you would sign an email can now be used to log into an online service. And this is a great way of going about things. It means that we never have to give our sensitive information out. We never have to type in a password. We are sending keys back and forth in a public and private pair. The public key can be owned by anyone. It doesn't matter who has access to that, because we are the only ones who have the private key, and that's what makes this secure.
Yeah, and for those of you, I know we're referring to other webinars, and that's because we've been building on this all year, but if you want a deeper dive, check out our webinar, How Encryption Works. And that's where we talk about the fact that public-private key encryption, you have a pair of keys, and what one key signs, the other key verifies. So that means you can have one key on your phone that you keep very, very secret, and one key that anybody has, which they can use to verify that it was in fact you. And so really having this key on your phone and then using your fingerprint or your face to unlock your phone is a very secure and very convenient method of authenticating.
It really is. Now, we get a question a lot about what happens, because we're now relying on a secondary device. What happens if we lose or have our device stolen? Because cell phones get lost, cell phones get broken. People drop them in mud puddles. I mean, it does happen. So if you're looking at rolling out something like this inside your environment specifically, a couple quick recommendations. One, make sure that you have an easy method for your users to report that something has gone wrong with their device or that it's been stolen or something like that. Bring your own device. Implementations especially can be very, very unpredictable. You may not know the exact model or type of phone that you're working with. And basically just plan ahead for this to happen. Make sure that the users know how to report that this has been lost or stolen, how to get a hold of your IT staff, how to get those keys reset for their access into the environment. And then ideally have a method in place to wipe any sensitive data off of that device if it is in fact in the hands of someone who shouldn't have access. So let's talk about progress. So the move towards passwordless is not specific to one hardware or software manufacturer. I mean, this is an industry-wide shift that we're trying to accomplish right now. And one of the big drivers behind this is a group called the FIDO Alliance. So they've developed technical specifications for universal authentication frameworks and universal second factor frameworks. I know those are kind of jumbly industry terms, but really what they're talking about is standardizing how we perform passwordless authentication and making sure that it can run across the board throughout multiple different kind of software and hardware applications. There's a lot of meat behind this group too. I mean, if we want to look at some of the members of the FIDO Alliance, we see big names. We see Amazon, American Express, we see 1Password, we see Microsoft, US Bank. These are big names in the industry, and they are absolutely driving this kind of move forward for a good reason. This is a much more secure method of authenticating. It's a lot easier, it's faster, and it's really just kind of where we want to be. So there's a few principles that we want to look at with FIDO's basic authentication standards. We want to require explicit informed consent for any operation using personal data. We'll talk about where your authentication data is actually stored here as we go through. We want clear context to the user for any FIDO operation.
I think I see here, like, some of the common questions we get are like, well, don't you get nervous about using biometrics because then you can't change your thumb, everybody's going to have your data? No, one of those core FIDO privacy principles is number 6. Biometric data must never leave the user's personal computing environment. And typically it's set up in a way so that it's not even directly used. Like, there's math that's done using your fingerprint or your facial recognition.
So we do get a question though, and that is, where exactly is this data stored? And each device or sensor that you're using has a unique database file that it's going to use. It's going to be on the device itself, whether this is a YubiKey, whether it's your phone or anything else. So that information never actually has to leave your device. That's one of the big things that we want to talk about. So let's see how this actually works. When we register a FIDO device, something that is going to act as that universal second factor, it's a very, very simple process. We go to the service that we want to, we tell it we want to use FIDO authentication. It's going to send out a notification to our compliant device. So that's probably going to be like a cell phone or something like that. We're going to unlock that with a fingerprint. It's going to generate our public-private key pair. The public key, which anyone can have, is sent back to the application, and the private key stays on your phone. That means that no sensitive data is actually transferred back and forth here. Now, when you go to log in, it becomes even easier. You go to the website, you tell it you want to log in, and the web service will send a challenge to your phone. You put your finger on the fingerprint reader, it selects the appropriate key, it signs that challenge and sends it back to whatever service you're logging into, and because it's got your public key already, it just verifies that you are who you say you are right there. There's no need for a password at this point, and you're into your service without really any kind of fuss or muss at that point. Very, very easy system to use, and your users honestly will probably appreciate something that's this easy.
Thank you so much, everyone. Again, this is Sherry Davidoff, CEO of LMG Security.
And I'm Matt Duran, Director of Training and Research for LMG Security. If you have any questions, please feel free to reach out at any time. We would love to hear from you. You can reach us at info@lmgsecurity.com, find us on LinkedIn, or follow us on Twitter. Thanks again for joining, and we'll see you next time.